On April 23, 2024, at 14:37 UTC, Commander Tessa Harlow, 41 years old, veteran NASA astronaut with 14 years of mission experience and former Air Force test pilot, was conducting routine sensor calibration aboard the Juno spacecraft in Jupiter orbit when the impossible happened. The spacecraft was positioned 174,000 miles above Jupiter's cloud tops, passing through a region of space that had been mapped, measured, and monitored by 6 previous missions over 4 decades. Empty space, cold radiation, nothing remarkable. Until the gravitational sensors registered an anomaly that violated every principle of Einstein's general relativity. The readings appeared first as a flicker on Tessa's display panel, localized space-time curvature. No corresponding mass. She ran diagnostics twice, then a third time, following protocol drilled into astronauts until it becomes reflex rather than thought. The gravitational signature measured 0.003 solar masses, concentrated in a sphere 47 kilometers in diameter. To generate that curvature naturally would require an object with the mass of roughly 600 Earths, compressed into a volume smaller than Rhode Island. Jupiter's entire gravitational influence registered on the same instruments without error. The calibration data from an hour earlier showed perfect baseline readings. This was not equipment malfunction. This was something in the space between Juno and Jupiter's magnetic field that curved space-time itself. And it had appeared in the 11 minutes since the last automated scan. Tessa's hand moved to the communication panel, muscle memory from hundreds of training simulations, but she paused. The anomaly's position placed it 280,000 kilometers spinward of Juno's current trajectory, deep within Jupiter's magnetosphere, where radiation levels would fry unshielded electronics in 47 seconds. No probe had ever survived there. No natural object should be stable there. The magnetic field lines twisted and compressed in that region, with forces that could tear apart planetary moons. Yet, the gravitational signature held perfectly still, as if anchored to something that did not move, did not drift, did not respond to the largest magnetic field in the solar system, aside from the Sun itself. She keyed the secure channel to Houston. "Flight Juno, we have a situation." The response delay should have been 43 minutes. Speed of light from Jupiter to Earth, 46 light minutes at current orbital positions, minus 3 minutes for relay processing through the deep space network. Tessa expected to continue her work, document the readings, prepare a detailed report for when Houston's response arrived. Instead, the comm panel lit up in 18 minutes. Impossible, unless someone at Houston had started transmitting a response before she had sent her message. Unless they had been waiting for this call. Dr. Nora Chen's voice came through with the clarity of near-Earth communications, though Tessa knew the woman was speaking from mission control in Houston, 500 million miles away. "Juno! Flight! Hold position. Do not approach the anomaly. Await further instructions." There was something in Nora's voice that Tessa had never heard in 4 previous missions together. Not uncertainty. Control. The kind of controlled tone that came from reading a script. Tessa glanced at her crewmates. Marcus Reeves, 38, systems engineer, who had spent 6 years designing the redundancy protocols that kept Juno operational through Jupiter's radiation hell. Ethan Park, 44, plasma physicist whose models of Jupiter's magnetosphere were taught at MIT. Both men were staring at their own displays, running their own diagnostics, arriving at their own impossible conclusions. The gravitational anomaly was not alone. Tessa's sensors had detected the mass signature. Ethan's plasma instruments had found something else. "Tessa, Ethan said quietly, his eyes fixed on the electromagnetic spectrum analysis scrolling across his monitor. "It's transmitting." The signal was faint, buried beneath Jupiter's overwhelming radio emissions, but it was there. A repeating sequence in the megahertz range. Not random static, not natural pulsar rhythms, a pattern. Ethan isolated it, filtered out Jupiter's background roar, and played it through the cabin speakers. The pattern repeated every 11 seconds. Prime numbers: 2, 3, 5, 7, 11, 13, 17. Then it shifted. Fibonacci sequence: 1, 1, 2, 3, 5, 8, 13, 21. Mathematical constants that had no business existing in the radiation chaos of Jupiter's magnetosphere unless something was deliberately broadcasting them. The temperature readings came next. Marcus pulled the data from Juno's infrared sensors, designed to measure the thermal signatures of Jupiter's atmospheric layers. The anomaly registered absolute zero. Not near zero. Not theoretical background temperature of space. Absolute zero. 2.7 Kelvin colder than the cosmic microwave background, which was physically impossible because nothing in the observable universe could be colder than the leftover heat of the Big Bang itself. Yet this object, structure, whatever it was, existed at a temperature that violated thermodynamics while simultaneously radiating electromagnetic energy in organized mathematical patterns. Tessa made the decision that would end her career with NASA, though she did not know that yet. She activated Juno's high-resolution imaging array and pointed it toward the coordinates where gravity, mathematics, and physics itself seemed to have broken down. The image that resolved on her screen 17 minutes later was not debris, not a moon fragment, not any natural object formed by accretion and gravity over billions of years. It was a structure, geometric, deliberate. The edges met at angles that her mind struggled to process, corners that seemed to exist in more than 3 dimensions, surfaces that absorbed every wavelength of electromagnetic radiation except for 3 narrow bands where it reflected with perfect efficiency. The structure measured 47 kilometers across at its widest point, and it hung in Jupiter's orbit like a door that had been left open in the fabric of space itself. Houston's second transmission arrived 31 minutes after the first, 12 minutes faster than light speed should have allowed. Juno, flight. Abort mission. Initiate return trajectory immediately. All data files are to be encrypted and quarantined upon arrival. This is a National Security Directive 5-4 Alpha. Acknowledge. Tessa had never heard of National Security Directive 5-4 Alpha, but she knew what 5-4 meant. The same classification used for orbital nuclear weapons platforms, for threats to national security that originated beyond Earth's atmosphere. She looked at Marcus and Ethan, saw in their faces the same question that was forming in her mind. How long had NASA known this thing was here, and why had they sent them, to find it now? The decision to disobey a direct order from NASA Mission Control was not one that Tessa made lightly, but it was one that every astronaut trained for in the quiet spaces between simulations and procedure manuals. There existed a protocol, unwritten but understood, that when faced with data that contradicted official explanations or when institutional responses moved too quickly to be organic, the scientist within the astronaut had a responsibility that superseded the employee within the government contractor. Tessa had 93 minutes before Juno's trajectory window for Earth return would close. 93 minutes before the orbital mechanics of Jupiter's gravity would require a burn that would consume fuel reserves and commit them to a path home. She looked at Marcus and Ethan and asked the question that she already knew would define the rest of their careers. We have time for one high-resolution scan at 50,000 kilometers. Close enough for detailed imaging, far enough to maintain safe distance from the radiation zone. Do we use it? Marcus responded first, his engineer's mind already calculating fuel margins and return vectors. If we deviate from the abort trajectory, we violate direct orders from flight. National Security Directive means this goes beyond NASA. Could be DoD, could be NSA, could be compartmented programs we don't have clearance to know exist. They told us to encrypt and quarantine data on return, which means they're expecting us to return with this data, which means they know what we found because they've seen it before. His voice carried no fear, only the methodical logic of a man trained to solve problems in vacuum. But they also sent us here, on a mission extension that was approved 8 months ago with objectives that included high-resolution magnetosphere mapping in exactly this orbital region. Someone wanted us to find this. The question is whether the someone who wanted us to find it is the same someone who just ordered us to run. Ethan was running spectral analysis on the electromagnetic patterns still streaming from the anomaly, his fingers moving across the keyboard with the practiced rhythm of a concert pianist. The signal sequence is repeating, but it's not static. There are variations every 11th cycle. Fibonacci sequence shifts to Lucas numbers, then back, then prime gaps, then what looks like… Hold on. He pulled up a secondary screen, overlaying the frequency pattern against a database of known mathematical constants. This isn't random variation. It's a response pattern, like it's answering a question. Except we haven't asked any questions. Our sensors are passive receivers. We're not transmitting anything except standard telemetry back to Earth, and that's encrypted, compressed, and wouldn't register on these frequencies anyway. He paused, and when he looked up at Tessa, there was something in his expression that she had seen only once before, during a simulation where the scenario writers had created an unsolvable problem just to see how crews responded to impossible choices. Unless it's responding to telemetry we sent 43 minutes ago. Except the response started 18 minutes ago, which would mean it received our transmission 25 minutes before we sent it. The implications of that statement settled into the cabin like a pressure change before decompression. Causality violation. Effect preceding cause. Signals arriving from the future, or from something that existed outside the linear flow of time that governed every other phenomenon in the known universe. Tessa felt the weight of it, not as fear, but as the intellectual vertigo that came from standing at the edge of a paradigm shift, the moment when everything you understood about reality revealed itself to be incomplete. She had felt this once before, reading about quantum entanglement for the first time, the way particles could influence each other instantaneously across distances where light would take years to travel. As if space itself was a convenient fiction that deeper laws of physics could ignore when convenient. But that was mathematics on paper, experiments in laboratories, phenomena measured in fractions of nanometers and picoseconds. This was a structure 47 kilometers wide, broadcasting organized information and bending the rules that Einstein had written a century ago. "There's precedent," Tessa said quietly, pulling up archival data from Juno's historical database, mission records that every deep space probe carried as reference material. Pioneer 10, 1973. First spacecraft to reach Jupiter. Experienced unexplained deceleration during flyby. Not much, 0.0008 astronomical units per year squared, but measurable and consistent. NASA called it the Pioneer Anomaly, blamed it on thermal recoil from radioisotope generators, except the math never quite worked, and 3 independent analyses showed the deceleration was too uniform, too directional. She scrolled through decades of data, mission reports, and declassified communications logs. Voyager 2, 1979. 14 minutes of corrupted telemetry during closest approach to Europa. Data came back in a format that JPL computers couldn't parse. They archived it as radiation damage and moved on. Galileo, 2003, final transmission before atmospheric entry into Jupiter. Last 8 seconds contained what the official report called structured noise. 3 engineers wrote classified addendums suggesting the noise wasn't random. Those addendums are still sealed. Marcus had pulled up the same files on his console, cross-referencing dates and orbital positions. Every mission to Jupiter's orbital space has reported anomalies. Every single one. And every anomaly was explained away with technical justifications that made sense individually, but form a pattern when you look at the aggregate. He highlighted a timeline that showed 47 years of missions, each one marked with incident reports that used language like equipment malfunction, solar interference, data corruption, sensor calibration error. The pattern is the cover-up. And if they've been covering this up since 1973, then what we're looking at isn't a recent arrival. It's been here the whole time. The second transmission from Houston arrived precisely on schedule, 43 minutes after their last acknowledgement, which meant it had been sent before they had responded to the first abort order. Dr. Nora Chen's voice carried the same controlled cadence, but this time Tessa could hear background conversations, multiple voices, the ambient sound of a control room that was far more crowded than standard mission ops. Juno, flight. Acknowledge abort sequence initiation. We are tracking your trajectory, and note you have not begun deceleration burn. Mission parameters have changed. You are ordered to return without additional data collection. Acknowledge immediately. There was a pause, and then Nora's voice shifted, just slightly, the script becoming personal for half a sentence. Tessa, please, just come home. Tessa looked at her crew. 2 men who had spent years training for a mission that was supposed to study atmospheric composition and magnetic field variations, routine science that would fill textbooks and doctoral dissertations but never make headlines. They had not signed up for this, had not agreed to violate national security directives or risk their careers for data that might get classified the moment they touched ground. But they were scientists before they were astronauts, and in the hierarchy of obligations that governed their lives, the pursuit of truth sat somewhere above the pursuit of job security. Vote, Tessa said. We scan at 50,000 clicks and risk our careers, or we abort now and spend the rest of our lives wondering what we could have learned. Show of hands. Ethan's hand went up immediately. Marcus hesitated for 11 seconds, counting silently, then raised his hand as well. For the record, Marcus said, I think this is catastrophically poor judgment. But I also think that whatever is out there has been waiting for 47 years. If someone wanted us to find it, they're going to get what they asked for. Tessa activated Juno's maneuvering thrusters and felt the gentle push as the spacecraft adjusted trajectory toward an impossible object that bent physics, transmitted mathematics, and existed at a temperature colder than the universe itself. She keyed the response to Houston, knowing it would arrive too late for them to countermand, knowing she was burning every bridge she had spent 14 years building. Flight, Juno. Conducting close approach scan per scientific mission objectives. Will comply with abort sequence following data acquisition. Juno out. The response from Houston, when it arrived 43 minutes later, would not come from Dr. Nora Chen. Juno's approach trajectory brought them to 50,000 kilometers from the anomaly over the course of 38 minutes, a controlled deceleration that burned fuel reserves Marcus had carefully rationed for the return journey, but that all three crew members now understood might not matter if what they were approaching represented something that rewrote the rules of what was possible in the solar system. The high-resolution imaging array came online as they crossed the 60,000-kilometer threshold, and the data that began streaming into Juno's computers was so far outside expected parameters that the automated processing systems flagged it as corrupted and attempted to shut down, requiring Ethan to manually override 17 different error protocols before the raw feed would display. What appeared on their screens was not the grainy, distant silhouette they had seen from 280,000 kilometers. It was architecture. The structure's surface was not smooth but tessellated, covered in geometric patterns that repeated at 7 different scales from meters to kilometers, each pattern interlocking with the others in configurations that Tessa's mind struggled to process because the angles were wrong. Not wrong in the sense of being irregular or imperfect, but wrong in the sense that corners appeared to meet at angles that added up to more than 180 degrees without any visible curvature of the surfaces themselves, as if the object existed partially in geometries that human eyes had not evolved to interpret. The material, whatever it was composed of, absorbed 99.7% of electromagnetic radiation across all frequencies from radio to gamma, making it darker than the darkest object ever measured in astrophysics, darker than the event horizon of a black hole when adjusted for relative scale. But in 3 specific wavelength bands, ultraviolet at 217 nanometers, visible light at 543 nanometers, and infrared at 10.6 microns, the surface reflected with 100% efficiency, creating 3 ghostly outlines of the structure that appeared and disappeared as Juno's sensors cycled through their scanning sequences. Ethan was running material analysis when he stopped, his hand freezing over the keyboard in a gesture that Tessa had learned meant he had found something that contradicted his understanding of physics. "The structure is reflecting neutrinos," he said, his voice carrying the careful neutrality of a scientist reporting data that could not possibly be correct. Not absorbing them, not allowing them to pass through, reflecting them. "I'm reading a neutrino flux from the sun that's hitting the structure and bouncing back at a 179.8-degree angle, which means near-perfect reflection, which is—" He trailed off, and Tessa finished the sentence for him. "Impossible. Neutrinos pass through everything. Through Earth, through the sun, through a light-year of lead. They barely interact with matter at all. That's why we need detectors the size of mountains buried underground just to catch a handful of them. Nothing reflects neutrinos." But the data on Ethan's screen showed exactly that. A stream of subatomic particles that should have passed through the structure as if it wasn't there, instead bouncing off its surface like light off a mirror. A phenomenon that violated every principle of particle physics and suggested that whoever or whatever had built this object understood forces that human science had not yet discovered. Marcus was cross-referencing the structure's position against historical orbital data, checking and rechecking his calculations with the intensity of a man who did not trust results that seemed too significant to be real. "I'm matching the structure's current coordinates against archived tracking data from Voyager 2's flyby in 1979, he said, pulling up files that were nearly half a century old, digital records that had been converted and reconverted through 6 different data format migrations, but that still contained the raw positional measurements of every object Voyager's instruments had detected during its grand tour of the outer solar system. There's an entry here. August 4th, 1979, at 12:41 UTC. Unidentified radar return, catalogued as probable debris, tagged for follow-up that never happened because the object was in Jupiter's radiation belt and assumed to be a fragment from volcanic activity on Io. He highlighted the coordinates. Same position we're looking at right now. Orbital elements match to within 0.003%. This structure has been in the exact same orbit for 45 years. The implications crashed through Tessa's understanding of what they were facing like a wave through a seawall. Natural objects did not maintain stable orbits in Jupiter's chaotic magnetic environment without constant corrections. The radiation pressure alone, the solar wind, the gravitational perturbations from Jupiter's major moons, all of it combined to create an orbital environment where anything not actively maintaining its position would drift, decay, or get ejected from the system within months. For this structure to hold the same orbital coordinates for 45 years meant it was actively compensating for every force acting upon it. Meant it had power systems that had operated continuously since before Tessa was born. Meant it was not debris or a derelict, but something maintained, something functional, something that was here with purpose. Tessa made the decision in the space between one heartbeat and the next, a decision that she knew would follow her for whatever remained of her career and possibly her freedom. She configured Juno's communication array to broadcast on open channels, bypassing the encrypted NASA feed entirely, and transmitted the raw scan data to 3 universities, MIT, Caltech, and the SETI Institute, institutions that would have the expertise to analyze what they were seeing and the independence to publish without waiting for government clearance. The transmission lasted 47 seconds. A compressed data package containing high-resolution imagery, spectral analysis, gravitational measurements, and the neutrino reflection data that would rewrite physics textbooks if anyone believed it was real. She was keying in the final authentication codes when the transmission cut off. Not from their end. The signal was intercepted, rerouted, terminated by an external source that had been monitoring their communications and had the technical capability to hack a spacecraft traveling 400 million miles from Earth in real time. Marcus stared at his console where the transmission log showed the cutoff, showed the rerouting signature, showed the electronic fingerprint of an intrusion that should have been impossible given the encryption layers and the sheer distance involved. "Someone's in our system," he said quietly. "Someone's been in our system. Probably since we found the anomaly. Probably longer." The response from Houston arrived 8 minutes later, far too quickly for bureaucratic approval chains, far too quickly for anything except a pre-planned contingency that had been waiting for exactly this scenario. The voice was not Dr. Nora Chen. It was a man Tessa did not recognize, speaking with the clipped authority of someone accustomed to being obeyed without question. "Juno crew, this is Director Caldwell, NASA Administrator. You are in violation of National Security Directive 54 Alpha, unauthorized transmission of classified data, and direct insubordination of mission-critical orders. You will immediately cease all scanning operations, initiate return trajectory, and prepare for debriefing under National Security Council oversight upon arrival. All data collected will be quarantined and reviewed under protocols established for orbital weapon systems and strategic defense information. You have violated federal law, and your continued employment, security clearances, and freedom of movement are now subject to review. Acknowledge compliance." Naol. Tessa had never heard of Director Caldwell, had never heard a NASA administrator invoke language about strategic defense and orbital weapons for an astronomical discovery, had never heard the agency she had served for 14 years speak to her with the tone reserved for threats to national security. National Security Directive. 5-4 Alpha was the classification used for nuclear weapons in space, for kinetic bombardment systems, for technologies that could end civilizations if misused. They were using that classification for a structure that transmitted mathematics and reflected neutrinos, and the only reason to do that was if they believed the structure represented a capability that equaled or exceeded humanity's most destructive technologies. 2 minutes before Tessa could respond, before she could initiate the burn that would commit them to Earth return, the structure pulsed. A single pulse of energy across the entire electromagnetic spectrum, a flash that registered on Juno's sensors as 10 to the 17th power joules released in 0.01 seconds, the equivalent of a 24 megaton nuclear detonation compressed into a time frame shorter than a human heartbeat. The energy was not directed at Juno, was not directed at anything, but radiated outward in a perfect sphere that would have been visible from Earth if anyone had been looking at Jupiter at that exact moment. Observatories around the world would have detected it. Amateur astronomers with backyard telescopes would have seen a flash on Jupiter's dark side bright enough to register on photographic film. NASA's public statement was released 6 hours later, before any independent astronomer could publish their observations, before any university could analyze their data, before anyone outside the compartmented programs could ask questions. Solar flare activity detected in Jupiter's magnetosphere. Standard plasma dynamics. No cause for concern. But Jupiter did not have solar flares. The Sun had solar flares. Jupiter had auroras, had radiation storms, had magnetic field variations, and the flash had come from coordinates where no plasma dynamics occurred, from a structure that NASA had just classified at the same level as orbital nuclear weapons. By the time the statement reached Earth's media networks, the raw data feeds from NASA's public observation satellites had already been edited, the flash removed from the timeline, the anomaly erased from existence as if 47 kilometers of impossible architecture could be made to disappear by deleting the evidence that it had ever been seen. Juno's return trajectory took 19 days, a journey through the solar system that should have been routine, should have been filled with the quiet satisfaction of a mission completed and discoveries made, but instead passed in a silence that had nothing to do with the vacuum of space and everything to do with 3 astronauts who understood that the moment their spacecraft touched Earth's atmosphere, everything they had witnessed would be classified, contained, and quite possibly erased from. Official record. They spoke little during the return, communicated with Houston only when protocol demanded it, and spent their off-duty hours reviewing the data they had collected, memorizing details that they knew might be the only version of truth that survived whatever debriefing awaited them. Marcus ran calculations on the structure's orbital stability, creating models that showed it should not exist in that position for 45 years without active propulsion, models that he saved to encrypted personal storage, knowing that Juno's main computers would be wiped the moment they landed. Ethan analyzed the neutrino reflection data 17 different ways, searching for any explanation that fit within known physics, finding none, and documenting each failed attempt with the methodical precision of a scientist who understood he might never be allowed to publish his findings. Tessa wrote everything down in a personal log that was not technically against regulations, but that she knew would be confiscated anyway. A detailed account of timestamps and coordinates, and the exact words Director Caldwell had used when he invoked national security protocols designed for nuclear weapons against 3 astronauts who had committed the crime of looking at something humanity was not supposed to see. They landed at White Sands Missile Range in New Mexico on May 12, 2024, not at Kennedy Space Center, where returning crews normally touched down, Not at Houston, where mission control waited with cameras and press conferences, but at a military installation in the desert, where the only people waiting were medical personnel in biohazard suits and security officers who escorted them directly from the landing pad to a quarantine facility that looked nothing like the medical. Observation units NASA used for standard post-mission health monitoring. The building was unmarked, surrounded by 3 layers of fencing, and equipped with communication jammers that Ethan identified within the first hour by the characteristic electromagnetic signature that disrupted his personal tablet's wireless connection. They were separated immediately, placed in individual rooms, and told the quarantine period would last 6 weeks for medical observation, which was 4 weeks longer than any previous deep space mission had required, and 3 weeks longer than the maximum incubation period for any known biological contamination. The interrogations, because that was the only honest word for what happened during those 6 weeks, were conducted by people who never identified their agency affiliation, who asked questions that demonstrated intimate knowledge of every decision Tessa's crew had made during their final hours near Jupiter, and who seemed less interested in what they had found and more interested in who they had told and what evidence might exist outside NASA's control. Tessa was asked 47 times, in 47 different phrasings, whether she had maintained any personal copies of the scan data, whether she had sent any messages to colleagues or family that referenced their discoveries, whether she had uploaded anything to cloud storage or external servers that might have survived Juno's data wipe. She answered truthfully every time because lying to federal investigators was a crime, and because she knew that everything they had transmitted to MIT, Caltech, and SETI had been intercepted before it arrived, knew that the 47 seconds of data she had tried to share with the scientific community had disappeared into the same classification system that had hidden this structure for 45 years. Marcus signed the non-disclosure agreement they presented him on day 39 of quarantine, a document that used language Tessa had only seen in classified weapons development contracts, language about permanent secrecy and consequences that included federal prosecution and imprisonment for violations. He signed because they offered him a position on the Artemis lunar program, a promotion he had been working toward for 8 years, and because his wife was pregnant with their second child, and he had responsibilities that extended beyond scientific curiosity. Ethan refused to sign for 11 days, argued that scientific discoveries could not be classified under national security law unless they represented immediate threats to public safety, argued that the structure near Jupiter was an astronomical phenomenon that belonged to humanity, not to government agencies, argued until the interrogators stopped arguing back, and simply informed him that his employment with NASA was terminated effective immediately for insubordination and violation of mission protocols. He returned to his position at MIT 3 weeks later, attempted to publish a paper on anomalous neutrino reflections in theoretical structures, and watched it get rejected from Physical Review, Letters, Nature, Science, and every other peer-reviewed journal he submitted to, not because the science was flawed, but because every rejection included the same phrase, subject matter outside the scope of current publication guidelines, which was academic language for, "We've been told not to touch." Tessa signed the NDA on day 43, not because she believed in it, but because refusing would accomplish nothing except extending her isolation, and because she understood that some fights could not be won through direct confrontation. She signed, and they released her, and she returned to her home in Houston to find that her personal computer had been replaced with an identical model that contained none of her files. Her phone had been upgraded to a new device with a different number, and her internet search history for the past 6 months had been scrubbed from every server that stored it. She was informed that she would remain on active NASA duty but would be assigned to public outreach and education programs speaking tours, and university visits, anywhere that kept her visible and occupied and far away from mission planning or data analysis. She accepted the assignment and spent the next 8 months smiling for cameras and telling students about the wonders of space exploration while feeling the weight of surveillance that never announced itself, but that she knew was there in the timing of cars that appeared behind her on empty roads, in the faces that repeated too often in coffee shops and grocery stores, in the way her emails sometimes took 3 seconds longer to send than they should have. The data leak happened in December of 2024, 8 months after Juno's return, and it came from a source that was not Tessa, not Marcus, not Ethan, because all 3 of them had been too thoroughly monitored to move information outside controlled channels. The files appeared on a server in Iceland, uploaded through routing protocols that obscured their origin, but that contained 47 minutes of high-resolution scan data from Juno's approach to the structure, spectral analysis showing the mathematical transmission patterns, gravitational measurements that demonstrated the impossible orbital stability, and a single image of the structure itself with scale references that showed its 47-kilometer diameter. The files were tagged with metadata that identified them as originating from NASA's Deep Space Network archive, which meant someone inside the agency, someone with access to classified storage systems, had decided that truth mattered more than career or freedom, or whatever consequences would follow, from whistleblowing on a cover-up that had lasted 45 years. Mainstream media ignored the leak. The New York Times did not report it. CNN did not mention it. The major science publications that should have been demanding explanations and calling for transparency instead published nothing, as if 47 kilometers of impossible architecture near Jupiter was less newsworthy than celebrity gossip or political scandals. But independent researchers found the data, verified its authenticity through technical analysis that confirmed it matched Juno's transmission protocols, and began asking questions that nobody in official positions would answer. The government's response was silence, not denial, which was somehow more damning than any confirmation could have been, because denial would have required engaging with the evidence, and silence simply pretended the evidence did not exist. Dr. Adrian Kovacs, a former NASA consultant who had spent 12 years working on theoretical propulsion systems before leaving the agency over disagreements about classification policies, was one of the first to connect the leaked Juno data with budget requests that had appeared in congressional records for the year 2023. Buried in 1,700 pages of appropriations documents was a line item for an anomaly research initiative, funded at $1.4 billion and classified under the same national security restrictions used for satellite reconnaissance programs and strategic weapons development. The timing matched. The budget scale matched. The classification level matched. And when Kovacs cross-referenced personnel transfers during that same period, he found that 3 astronauts, names redacted, had been reassigned from standard mission rotations to a program listed only as Special Access Required, which was Pentagon language for operations so classified that even knowing they existed required security clearances beyond top secret. Tessa received an unmarked envelope at her home in February of 2025, delivered not through postal service, but left in her mailbox by someone who had bypassed her home security system without triggering any alarms. Inside was a photograph, high resolution, taken inside what appeared to be a hangar or assembly facility, showing something large covered by protective sheeting. The shape under the sheets was wrong. Angles that did not resolve into familiar aerospace engineering, curves that suggested geometries human manufacturers did not use. In the bottom corner of the photograph, visible where the sheeting had pulled away, was a surface that absorbed light, that reflected only in 3 specific wavelengths that Tessa recognized because she had spent 19 days studying its structure through Juno's sensors. She did not respond to Adrian Kovac when he contacted her 3 days later asking for comment on his research. She did not confirm or deny anything. But 2 weeks after that conversation, Kovac received his own unmarked envelope containing technical specifications for components that did not match any known aerospace materials, mathematical models for field geometries that violated conventional physics, and a handwritten note that said only, "They're building one." NASA announced the Jupiter Exploration Initiative in March of 2025, a program that dwarfed the budget of the original Apollo missions when adjusted for inflation, with objectives listed as comprehensive study of magnetospheric anomalies and evaluation of Jovian orbital structures. The mission timeline showed a launch date in 2027, crew selection still pending, but the job posting requirements included security clearances that had never been required for civilian scientific missions, psychological evaluations that screened for adaptability to paradigm-shifting discoveries, and a willingness to sign non-disclosure agreements before mission briefings. Marcus Reeves was on the preliminary crew list. Tessa Harlow was not. The program's official description used careful language about advancing human understanding of the outer solar system, but the engineering specifications called for a spacecraft with capabilities that exceeded anything NASA had ever built, with power systems designed for sustained operations in high-radiation environments, with communication arrays that could function under electronic warfare conditions, and with life support rated for missions lasting up to 3 years, which was 2 years. Longer than any journey to Jupiter required, unless the mission involved something other than a flyby. Amateur astronomers, the global community of hobbyists who pointed telescopes at the night sky for the simple love of discovery, began reporting observations in late 2024 that should have made headlines, but that were dismissed by professional astronomers and ignored by scientific institutions that had chosen silence over investigation. The reports described lights near Jupiter, pulsing patterns that repeated every 47 days, increasing in intensity with each cycle. NASA's explanation, issued through standard press channels, attributed the lights to reflections from Io's volcanic activity. But Io's orbital period was 1.77 days, not 47, and the lights were appearing in coordinates that placed them 280,000 kilometers from any of Jupiter's major moons, in the empty space where no natural phenomenon should create visible illumination. The amateur astronomers compared notes, shared observations, and documented a pattern that professional institutions refused to acknowledge. The lights were getting brighter, measurably, systematically. As if something near Jupiter was powering up, activating systems that had been dormant, preparing for an event that no official source would discuss, but that everyone watching the data understood was coming. The structure near Jupiter, if it had been placed there deliberately, represented a truth that human civilization had spent centuries trying to avoid confronting. The truth that we are not the first intelligence to reach into the solar system, not the first to build in the space between worlds, and possibly not even the first to call this particular collection of planets and moons home. The mathematics of it were straightforward enough that anyone with undergraduate physics could work through the implications. If the structure had been in stable orbit since at least 1979, and if maintaining that orbit required active compensation for gravitational and radiation forces, then it had been operational for a minimum of 45 years, without any visible maintenance, without any resupply missions, without any sign of the decay that affected every human-made object in space, from satellites to space stations. The International Space Station required constant adjustments, regular supply runs, and component replacements every few years, just to remain functional. The structure near Jupiter had operated for nearly half a century in an environment that would destroy human technology in weeks, and it showed no signs of degradation, no signs of age, no signs of anything except deliberate purpose and a level of engineering that suggested its builders understood physics at a depth that made human science look like children playing with blocks. The Fermi paradox, the question that had haunted astronomers since Enrico Fermi first asked it in 1950, was built on a simple observation. If the universe is as old and as large as we know it to be, and if intelligent life can arise through natural processes, as it clearly did on Earth, then the galaxy should be filled with civilizations, should be crowded with radio signals and megastructures, and evidence of intelligence wherever we point our telescopes. The fact that we see none of that the universe appears silent and empty, creates a paradox that demands explanation. Either life is incredibly rare, or intelligence is incredibly fragile, or civilizations destroy themselves before they spread beyond their homeworlds, or they're out there, but choosing not to reveal themselves. Or we're looking in the wrong places with the wrong tools and missing signals that are obvious to anyone who knows what to listen for. The structure near Jupiter answered the paradox, but the answer it provided was not comforting. They were here. They had always been here. And the silence was not because we were alone, but because someone had decided we were not ready to know we had company. Tessa gave one interview in January of 2025, a single conversation with an independent journalist who specialized in scientific oversight and government transparency, and she chose her words with the precision of someone who knew that every syllable would be analyzed by lawyers and intelligence analysts looking for violations of the non-disclosure agreement she had signed. "The cosmos is larger and more inhabited than we've been taught to believe," she said, speaking carefully, speaking truthfully within the constraints that bound her. "There are structures in our solar system that challenge our understanding of physics, that demonstrate capabilities we don't possess, and that have existed in places we've explored for longer than we've been exploring them. The question is not whether we're alone. The evidence suggests we're not. The question is whether we have the courage to acknowledge that publicly, to move past secrecy and denial, and to have an honest conversation about what our place is in a universe that clearly contains other intelligences, other builders, other minds looking out at the same stars we see." 3 days after that interview was published, NASA announced that Tessa Harlow was being released from active duty for conduct inconsistent with agency values, which was bureaucratic language for speaking truth that institutions preferred to keep hidden. Her lawsuit against the agency for wrongful termination was still pending in federal court, delayed by motions and counter-motions and classification claims that prevented her from introducing the evidence that would prove her case. What we know, based on data that leaked despite classification, based on observations that amateur astronomers documented before they could be suppressed, based on the testimony of 3 astronauts who saw something impossible and refused to pretend it was ordinary, is that a structure exists in orbit around Jupiter. We know it measures 47 kilometers in diameter. We know it maintains stable position in an environment that should make stability impossible. We know it transmits organized mathematical patterns. We know it reflects neutrinos, which should be impossible. We know it has been there since at least 1979 and possibly longer. We know that NASA classified everything related to it at the same level used for nuclear weapons. We know they're building something that uses similar geometries and materials, something that requires security clearances and budgets that dwarf anything previously allocated to space exploration. We know Marcus Reeves is part of the new mission. We know the amateur astronomers are watching lights that pulse every 47 days and grow brighter with each cycle. These are facts, verifiable and documented, despite every attempt to erase them from record. What we don't know is who built the structure. We don't know when it was built, whether it's decades old or millennia old or older than human civilization itself. We don't know why it's positioned near Jupiter specifically, what significance that location holds, what resources or conditions make that orbit valuable enough to maintain for decades at minimum. We don't know what the mathematical transmissions say, whether anyone has successfully decoded them, whether they're messages or warnings or simply identification signals broadcasting to anyone who knows how to listen. We don't know if there are more structures in other locations, hidden in asteroid belts or on the far side of moons or in orbits we haven't surveyed with sufficient resolution. We don't know what the photograph in Tessa's envelope showed, what NASA is building in unmarked hangars, whether they're attempting to reverse engineer technology they found, or building something to interface with technology that was already there. And we don't know what the next mission to Jupiter is really for, whether it's scientific observation or first contact or something else entirely, something that requires astronauts with military clearances and psychological profiles that screen for adaptability to paradigm shifts. Jupiter is 400 million miles from Earth at its closest approach, a distance that light crosses in 33 minutes, which means that everything we observe happening near Jupiter is actually the past, events that occurred half an hour before we see them. When Tessa witnessed the structure pulse with energy equivalent to a 24-megaton detonation, that pulse had already happened 33 minutes earlier, had already released its energy into space, had already sent radiation and particles streaming outward in patterns we still don't understand. When amateur astronomers report lights increasing in intensity, they're watching something that's already brighter than what they can see, watching the past while the present unfolds unseen. And if the structure is activating, if the lights are powering up systems that have been dormant, if something is preparing to happen near Jupiter, then it's already happening now, in the present moment that we won't see for another 33 minutes, the present that exists beyond our ability to observe it in real time. The question is not whether we're alone in the universe. The structure near Jupiter answered that question. The question is whether we're ready for what comes next, whether we have the wisdom to approach contact with humility rather than arrogance, whether we can move past the instinct to classify and control and instead embrace the reality that we are not the apex of intelligence, not the masters of space, not even close to understanding how much we don't know. Somewhere between the frozen moons of Jupiter and the infinite dark of the outer solar system, there is a door. Someone built it. Someone placed it there with purpose and precision. It has been waiting for 45 years at minimum, possibly much longer, broadcasting mathematics to anyone who would listen. And now, after decades of silence and denial and cover-ups that erased evidence as fast as it appeared, the door is opening. The lights are getting brighter. NASA is preparing to return. And whatever happens next will redefine what it means to be human in a cosmos that we share with minds we're only beginning to comprehend. The only question that matters now is whether we'll face that future with eyes open, or whether we'll keep pretending that the shadows on the wall are the only reality worth acknowledging.